Our second class of Python level 2. I see we have the recording going, which is great. So I'm just gonna start off with some slide share, and there's not too much to review because yesterday, or last week I should say, was mostly just an introduction to Python 3, what we're gonna be talking about in this class. And that was exploring this library called Pygame, which allows you to create games, but in general, just draw things to a display and control things in a loop. And we're going to start diving into that more today. And there's some links. These are the same ones from before. And we're going to be looking at the documentation a little bit more today as well. And so that's this one on the slides. The only thing I do want to make a note of before we get started is I'm trying something new this time where I have the code uploaded in something called a GitHub repository. So on the Google Classroom, I posted a link to this repository, which will have all the code that we're working on in this class. And so you can see I have in separate folders, and class 17 was last week. And these were the files that we worked with then. Now I'm just going to be uploading whatever we do every week to here, so you can look at it, download it if you want to have a version of what I did in class. There's a couple ways to download, and I know it can be a little bit confusing, but you can click this green code button and download a zip, or if you have used GitHub before, you can clone and do all that. But I'm not expecting that to be familiar. You can just download the zip folder, unpack it, and you'll have all the files there. Or you can go to any specific file. So let's go to one from last week. Here's like the demo with the bouncing ball on the screen. You can see the code right here. You can either just copy it, paste it into PyCharm. You can also click this raw button, and it'll bring you to the code again. And what you can do here is now right-click, save as, and it'll automatically save as a Python file. And you can choose where to save the file to. But this is just a quick note of I'm going to be uploading all the code there. And if you have any questions of how to use it, how to see the files, how to download them, let me know, and happy to help. But with that out of the way, we can start with something a little bit interesting, in my opinion, which is with a Pygame example. So we've seen some examples last week, but I want to do an example that shows off more of what is capable with Pygame, sorry. And so for this, I want everyone to start up their PyCharm if they haven't yet already, or VS Code, or whatever you prefer to use. And we're going to run one of the built-in examples in the Pygame library. And so there's this example that someone else already coded called Chimp, and I'm going to show you how to run it really quick. So let me get my PyCharm opened up right here. And so what I did is I created a new Python file. So again, you can right-click new, and kind of in the top 1/4, there's this thing called Python file, and you can give it a name. At this point, the name that you give it doesn't really matter. Python doesn't have any rules, unlike other programming languages, but you can call it whatever you want. And because someone else already wrote this for us, what we have to do is very simple. All we have to do is a simple import statement, and then one line to run the example. And so the code that you see here is really all you need. A reminder, Pygame, it's called a Python package. A package is just a collection of files and folders that make up some interesting thing that someone wrote. And we've downloaded this package, and we want to import something from it. And so here we can see we're going from the main Python package, Pygame package. And then examples is a sub package from it. So pygame.examples is a package inside of a package. And from there, we're going to import this module, the chimp module. And by importing the chimp module, we get access to basically this demo game that someone else wrote. And to run it, we just say chimp.main. Right? And once you do this, all right, let me make sure. I'm going to share sound really quick. You'll see kind of a it's still kind of basic game, but a little bit maybe more involved than what we've seen before. We see this display. We have kind of an animation of this monkey going back and forth. And you can see his head turns every time he hits the sides. And we have a fist that follows our mouse, right? And this is a very simple game. So you can see by the title, the idea is you just want to hit the monkey to get money. It's meant to be like, there are ads that look like this in the past, but you can see if we hit the monkey, we get a sound effect and an animation. And if we miss, we get a different sound effect. And so this just kind of shows off some of the things that Pygame lets you do. It lets you create a window, you can write text, you can have images on the screen, you can animate them, you can control or kind of manipulate what your mouse does. Or another way to put it is you can get information about where the mouse is, and from that you can control things inside the game. And you can have sounds, everything. And all this is just like a loop, so it just keeps running and running and running. So you can just keep playing, you can hit the monkey, and then when you're done, you can just close it and everything ends. So that's just one of the examples in the Pygame library, just to get you interested, I guess. Hopefully it's a little bit more fun than just the bouncing ball that we saw last week. But we're gonna start diving into kind of how all this is created and how you can eventually make your own games. And to do that, we're gonna go back to an example, the most basic example that we saw last time. So I have the code here. I pasted it into chat, but you can also, since we have the GitHub repository, I think I have it here. So there's two ways you can get this code. You can follow the link, or you can copy it from the chat message. But this, if you remember, if you run this one, so right click run, just opens up a window with a black screen. And that's all it does at the moment. We're actually gonna start make this do something slightly more interesting in a little bit. But for now, all it does, opens a window, it's a black screen, that's it. So if you can, take that code, copy it into your PyCharm, and we're ready to get started. Yeah, the title says a cool game, but it might not be cool yet, but we're gonna make it cool. Yes. Here. So the first thing that we want to learn is how to create the window, or how, well, the window is being created by this code, but how is it done, right? What in Pygame controls all this? And it's pretty simple. It's all about this display module that we're going to see. So we see that in our code, kind of one of the first things that we do is we create this variable called screen. We do this pygame.display.setModeSize. And then we do some more display things. So display.setCaption, and then here display.flip. So we see it 3 times in our code. And we want to know, what in the world is this doing, right? And so whenever you have a question like this, don't know what this function, don't know what this module is doing, best place to go, documentation, right? And so if we just go to the documentation, pygame.org/docs, paste the link in chat if you want to follow along. The display documentation is in the kind of the bookmarks bar, most useful stuff. Second one is display. And that goes to show it's very important in how Pygame works. But you can start seeing a list of everything in there, and then a little bit more in depth on each one. And so we can go in order really quick. We can see the ones that we're using. So the first thing that we're doing is set mode, right? So in line 4, we're doing pygame.display.setMode size. And size here is just a tuple that we created that has 2 values, 800, 600. And you can guess this is going to control the size of the screen. But if we look at the documentation and make sure, and we can just search set mode, you'll see this is the documentation for it. And I'm not going to sit here and read everything here for you, but the important thing to be able to understand is kind of this line right here, right? And so this line isn't real code, but it tells you what's going on. It tells you how the function is defined and what it kind of does in a way. And so we see the set mode function takes a couple parameters, size, flags, depth, display, vsync, and the arrow tells us the return value. And so what's after the arrow? It's a surface, whatever that is, right? So this is a function, takes in these different parameters and returns a surface. Really quickly, does anyone remember what we called this, like when we have this equals 0 here, or equals the tuple 0, 0? It's a special type. This parameter has a blank. So when we define functions, we could do something for some of the parameters. We could give them a default value. So this function takes in a bunch of parameters, size, flags, depth, display, vsync, and you can read about what all of them do. But luckily, they all have a default value, which means that they're kind of optional. You don't have to pass in a value for it. And if you want to know what the default value is, then you have to start reading into the documentation. But for one just example of it is the size, right? So here we're passing in a tuple 800, 600 for the size. But it says that if no size is passed, or if we pass in the tuple 0, 0, it doesn't create a window that's tiny and not visible. Instead, it'll figure out how big your computer screen is and make it that size. And so we can test it out. For example, if let's just get rid of the parameter, right? And I'm going to stop it. I'm going to rerun it. And now you can see the window takes up the whole screen, right? Instead of being a set size, it figured out how big my computer is and created the screen that big. Right? It'll be different for yours if you have a different size computer. But you can see that's one of the parameters that we can mess with. If you ran this on your own computer and are stuck, you can always hit Alt-Tab to go back to your PyCharm, and then you can hit the red stop button to close the program and get rid of the window. And I'm gonna put the size back in. So this set mode will basically set up your whole display. You give it some initial parameters, it creates it that size, has some flags, and then it returns a surface to you. And so what is a surface? Well, really quickly, we're not going to get into that right now, but a surface is basically just an image. And you can draw things onto surfaces. So this is how you'll like draw the monkey or the fist onto your screen. Basically, you can take an image and draw it onto your surface. And so when we create this display, we create an initial surface for us to work on. You can think of it as like a real world painting, right? You have a canvas, a piece of paper that you're drawing onto. And so that's what a surface is in Pygame, something that you're going to draw other things onto. The other thing that's important here is really the flip. And so if you notice in our code, there's this while loop. We have this while loop, and the main thing that goes on here is just this pygame.display.flip. And if we look at the documentation, I'm not going to show it here, but essentially what flip does is it will update your screen. And so we just said your screen is a surface that you can draw things onto. Well, when you draw things, it doesn't immediately update what you can see. What you actually have to do is call this flip method before it actually shows up on someone's screen. And there's a lot of good reasons for this. You might have a lot of things to draw, and you want to make sure everything's finished before you actually put it on the screen. So you don't have the user see things like drawn like half of the way. You want to wait until it's finished, and then you update the display. And so this line is what does the updating. But there's also another version of this, and instead of calling it flip, there's also an update method. And this is basically, if you don't want to update the whole screen, but you only want to update a part of it, this is what you're going to use. And we're going to see this more than just now. But it's going to take in a rect object. And I think we very briefly saw rect objects last week. It's just a rectangle, it has like a bounding box, it has a chord, it knows where it is and how big it is. And so you can imagine this update function can take in a rectangle and say, oh, this rectangle is maybe kind of near the bottom left corner. I'm only going to update the screen inside that rectangle, and everything else is going to stay the same. It could have like performance benefits because maybe your screen's really big and only a small thing changed. So you don't need to update the whole screen. You just only need to update the part that has changed, actually. And so that's the display. And the other main thing in this loop, in this code, is the loop. So after I create this display, you'll see that we create this variable, crashed equals false. And we basically say, while it's not crashed, we're going to do this over and over and over and over again. This for loop, this for is not too important right now. So I'm almost just going to ignore it. And if we ignore it, like I'm just going to comment it out, for example. This loop basically does nothing, right? It updates the screen and it goes back to the start. And if you notice, we never change crashed, right? Crashed never is updated. So this is essentially an infinite loop, right? And a lot of the things that you're going to see in Pygame is going to have this thing, this main loop. We can call it the game loop. And if you think back to the monkey, the chimp game, that just has a loop of the monkey going back and forth, the fist following the mouse, and it just does that forever, pretty much, until you hit the X to close the window, right? And so that's really what the main game loop is. And it just runs. It runs multiple times a second, we're going to see. And it just handles all of your logic. So pretty much all of your logic is going to go inside this loop. And so that's really important. One thing we might want to know, though, is how fast is this loop going? In games, there's often a term called the tick speed or ticks. And that's basically how many times per second does things in the game update, right? So if you have 60 ticks, that means it updates 60 times a second. If you have 1 tick, it will update 1 time a second, right? And so we want to know, how fast does Pygame operate on, right? That's a pretty interesting thing to find out, right? So we can do this by first modifying the loop so that it will crash after 1,000 times, right? So if in our loop, we create a variable, or outside the loop, we create a variable count. And inside the loop, every time it runs, we're just going to increase it by 1. And we're going to check, has count reached 1,000 yet? And if it does, we're going to crash, we're going to stop the loop. All right. So here, I'm going to say count equals 0. While it's not crashed, before I update the screen, I'm going to say count plus equals 1. And so again, this is adding 1 and then setting it back to the same variable. So it's just going to increment by 1. And then I'm going to add a check. If count is greater than 1,000, I change my variable, crashed equals true. So we can see here is now the loop will stop after a certain amount of time, right? Because every time the loop runs, count gets higher and higher and higher. And eventually it's going to pass 1,000. And whenever that happens, crash is going to be set to true. And then the next time we go and try to loop, well, if crash is true, not true is going to be false. And so the while loop is going to stop, right? And something I didn't say, but is actually in the documentation. If your Python program finishes, your display will automatically close, right? So the display that we created here is going to automatically close once we reach the end of this program. And so before we never reach the end because we get stuck in this infinite loop. But now this loop is going to eventually stop and our program is going to reach the end and we're going to close automatically. So if we try this, you'll see it starts up. And hopefully if we wait a little bit, it was pretty fast, but you can see I didn't click anything. The window just closed, right? I can run it again. You can see maybe it's like 1, 2, 3, maybe about 3 seconds to do 1,000, right? But we can actually time this a little bit more accurately. So in Python, there's ways to do this not related to Pygame. So there's this time module that you can import. And once you import the time module, you can get the current time using this time.time function. And if you just get it at the start of the loop and at the end of the loop, you can figure out how much time has passed between those two, right? So I'm just going to do it here. Typically, you put your imports at the top. So I'm going to put it there, import time. And I can say, before we start the loop, I'm going to say start time equals time.time. And after the loop finishes, so outside the while, I'm going to say end time equals time.time. And I'm going to print end time minus start time. And that will just get me the difference, like, so how long the stuff in the middle took. And just because I think maybe it's a little bit interesting, I'm also just going to print the start time and the end time separately. So you can see what individually they look like. So if we run the program now, again, we wait about 3 seconds and it will stop. And you can see kind of the output here. So time, don't think we covered this, but this is something called Unix time. Basically, it measures the amount of seconds, or in this case, like almost like milliseconds, or even a little bit more precise, but basically seconds since a special time in the 1900s. And so you can see this is pretty much all the same, but this is 268, this is 271. That's about a difference of 3, and we can see the exact difference is about 2.6 seconds, right? So my estimate was pretty accurate, actually. We can see it takes about 2.6 seconds to do 1,000, we can call it frames, right? So you might hear like frames per second. Here we're updating 1,000 times every 2.6 seconds. And so we can do the math. If we do 1,000 frames in 2.6 seconds, that's just going to be about 300 or so. But just 1,000 divided by 2.6, that's going to be about 384 updates a second. And so that's really fast, right? And partially the reason for this is because our loop doesn't really do much, right? There's not much to compute inside our loop. It doesn't cost a lot of effort. And so our loop basically just goes really, really fast. You can imagine though, if we had something a little bit more time consuming, then it might start taking a little bit longer. I don't know if there's a way to show it off easily, but like you can imagine if we've seen some like recursive functions that take quite a reasonable amount of time to finish. For example, the Fibonacci recursive function, I showed you sometimes it will take forever to finish, but like sometimes it'll take like a second or so to finish calculating. So if we put that inside the loop, then we start limiting ourselves of how fast can we do this. Right now, we don't really have anything to limit because we don't have anything in the loop really. But there's another way to limit how fast the game updates. And there can be a lot of good reasons why you'd want this. For example, like it's always good to have consistency. And so if you can make sure that it's always updated 60 times a second, that's probably better than sometimes it's 30, sometimes it's 100, it changes all the time. Can be a little bit random. And maybe you want that, but in general, you want consistency. I'm glad, Derek, that you remember. But in Pygame, there's a way to do it. And that's by using something called a clock. But I did get ahead of myself. Here, we're using a built-in thing to Python. It's completely unrelated to Pygame, this time module. But Pygame has its own way of keeping track of the time as well. And it's related to this thing called ticks that I said before. And so there's just a pygame.time.getTicks function. And it gets the number of milliseconds since a init was called. So here we call init. Kind of glossed over this. Init is basically just as short for initialize. Basically, there's some things in PyCharm that needs setup before it can be run. And so pygame.init just makes sure everything is set up, ready to go for us. And you can see it's actually what's printing out. You might have noticed there's like a couple lines that are printed out, the version and just like a link to their website. This is all caused by init. That's all the setup that it has to do. But getTicks just measures how long has it been since we've called init. And so we can try it. So actually, I'm going to copy the whole thing. Print pygame.time.getTicks. So we can do it before we start. And we can do it before we end. And I'm going to get rid of the stuff about the time. And if we run it again, we wait about 10 seconds or 3 seconds. Here you can see what it did. So here, the first time we called it, right here, before the start of the loop, it said 1,243 milliseconds have passed. And if you're not familiar, a millisecond is just a thousandth of a second. So 1,000 milliseconds is 1 second. So this is basically saying it's been 1.2 seconds since I've initialized Pygame. Then at the end of the loop, it says it's been 3,600 milliseconds. So that means in between here, it's been about 2.4 seconds. And you can see this took a little bit shorter than before. And again, this is all just because it's a little bit random right now. We try it one more time. You can see the start is a little bit different. The end is a little bit different. Here, it looks like it's still about 2.4. So that looked like it changed not that much. But you can see the exact numbers have fluctuated a little bit. What we can do to control the speed is by using this pygame.time.clock class. So this clock class has a function called tick, and it basically limits the frame rate, how many times it can be run in a second. And so this tick function takes in a number, and it basically just says, it just controls how fast the loop can be run. And if we say tick 40, it means it can run at most 40 times a second, or 40 frames a second. And so if I take this, put it into chat, and I put it inside the loop. So a weird thing about this one is it has to be called every single time. You can't just do it once. You have to keep calling this function. But now if we run the code, we should hopefully see something a little bit different. Well, this actually might be a mistake because it's going to take a long time. So actually, let me stop this. Let me change the stopping condition. Instead of 1,000, I'm going to change it to maybe 200. Or actually, so it's a nice even number, 240. So I'm going to run this code again. We're going to wait a little bit. This should take about 6-ish seconds because, and if we look, it's not perfect, right? But if we take the difference here, it's about 6.5, looks like, right? 77 minus 12, that's 6 or 65 or 6.5 seconds. And so the reason for this, why it took a lot longer, even though I decreased my limit, now I'm stopping once it reaches 240 instead of 1,000. It still took a lot longer because we're limiting how fast this loop can run. So here I'm saying tick 40, which means at most run this loop 40 times a second. And so if this only runs 40 times a second, and we're stopping when it reaches 240, well, we can divide 240 divided by 40 is 6. And so at the very least, this is going to take 6 seconds to run because we're limiting it. It can't run more than 40 times a second. We have to run it 240 times for it to stop. It has to run at least 6 seconds. And so this is a way to control your frame rate. Oftentimes we want to update maybe like 30 or 60 times. Those are pretty common. Basically, we typically want to update fast enough so that things like animations, right? Animations are something that we're going to update in our loop. And how animations work typically is that we'd have an image, and every single time we just like move it a couple pixels. And so in reality, the image is doing this. Still, it jumps, it jumps, it jumps, it jumps, right? But because it jumps so slow, and because we're doing it multiple times a second, our eyes just perceive it as moving smoothly, right? And so you want to have a frame rate fast enough so that it looks smooth. It doesn't look choppy, but you also don't want it too fast, or else then it's just going to like bounce back and forth insanely fast. For example, if we go back to maybe the ball one from last time. So here we have the demo that I had you try out. You can see it, they have their own loop here, while one. So this is something that's a little bit tricky. One is equivalent to just true. So this is equivalent to saying while true. So this loop just runs forever. But if we just limit, or let's see, let's run this without a limit, and we can see that it runs really, really fast, right? The ball is moving really, really fast. But if we start limiting how fast this loop can run, for example, 40, and run it, now you can see, I don't know, to my eyes, it's a little bit like, I can see it stuttering a little bit. And maybe when I share it through Zoom, it is a little bit worse. But you can see it's definitely moving a lot slower than before. And that's because we're not updating as often. All right, I think I'm back. Yeah, sorry about that. But if we just change this to maybe 100 or 100, we can see now it moves almost double the speed. And if we change it to 10, you're gonna see, you can really see it like just, it's stuttering. It doesn't look smooth. And this is all just based on how fast are we updating the screen. Right? And you could take it always to the extreme, like tick 1. So now it's only updating 1 time a second, and you can really see it now, right? And so Derek, what happens if you put a negative number? That's a great question. Personally, I don't know myself, but there's a couple of things that we could try. First, we can just do it. So if I say like negative 100, we can see what happens. Looks like it just ignores it. That's what it looks like to me. But the best way to confirm is if we go to the documentation page, it will definitely say, it'll describe the behavior. So for example, let me zoom back out. And so I see time right here and clock right here, clock.tick. And okay, so it doesn't say explicitly, but it says this method should be called once per frame. So it has to be called inside the loop. It has to keep being called. And it will compute how many milliseconds have passed since the previous call. And basically it's saying, don't continue until this many milliseconds have passed. And so if you put a negative number, it basically does nothing, because if you put a positive number like 100, it's saying, make sure the next time this runs, it's been 100 milliseconds, right? But if you put a negative number, that's almost like you're going back in time instead of in the future. And so it's saying the next time it runs, it better be before now. And so of course it's going to be before now, and it doesn't limit it in any way. So a negative number, it doesn't crash. It doesn't give you error messages. It basically just does nothing. Okay. Check on the time. We're doing great. So that's 2 things, the display and controlling the time of our game. The last thing that we're gonna do today is discuss color. Just really quickly, how many of you guys are familiar with the concept of RGB values? Red, green, blue values for color. Evan says me. Derek has a red hand raised. All right. If you don't know, that's perfectly fine. But RGB is a way of basically encoding a color into 3 numbers, specifically a red value, a green value, and a blue value. And the numbers basically represent how much of each color is present. So if you have a color that's really, so the red color would be 255,000 because it's only red and nothing else. While like a purple color might be 255,255. It has a lot of red and it has a lot of blue and little or no green. And these values can go from 0 to 255 for each R, G, and B. And one way of really quickly seeing this and playing around with it is Google has a built-in thing. If you say color picker, you can see a color. So this changes kind of based on the rainbow. This changes how bright it is, how dark it is. So you can pick a number and see this is 25, 221, 224. And that kind of makes sense because it's really blue. So the blue value is really high. And it just happens that this kind of light blue color has a good amount of green mixed into it as well, but not much red. And if you look at this bar, it kind of makes sense because blue is here, green is here. It's kind of in the middle of the two. So it makes sense that it has a lot of blue and green, right? And if we look at like purple colors again, so here's my color. It's very red, it's very blue, and no green pretty much. If I change the lightness and the darkness, it might add some green to change the value. But that's just RGB really quickly, is taking a color and turning it into the red, green, and blue channels. How much red, how much green, how much blue. And you can do this for pretty much any color. This is not the only way of encoding a color really quickly. So you can see there's CMYK, that's cyan, magenta, yellow, and I think like brightness is K, not too sure. HSV, hue, saturation, something. HSL is hue, saturation, lightness. So there's a lot of different ways of encoding colors, but we're gonna focus on RGB for the most part. That's just because that's what PyCharm does by default. Pygame, sorry. So we can see some things really quickly. So if we go to PyCharm and put this code in, let me make a new Python file. So I'm gonna need to import Pygame. But you can see something kind of interesting here. What I'm doing is I'm taking Pygame, going into the color dictionary, getting the colors and getting the items. And so this is a dictionary, I'm getting everything in there and I'm printing it out. And this code isn't too important, but what it gives you is basically all the named colors in Pygame. And so there's a lot of colors that we're gonna use a lot that are just like pretty common. And so they're kind of just built into Pygame. For example, there's a couple of different blues and whites. Aqua is this color. And it gives you the name of it. And it also gives you, I believe, what's RGBA. So A stands for alpha or transparency. And so here it's no red, all green, all blue. And so if we take that to this Google thing, I can actually enter this. So 0 red, 255 green, 255 blue, and it gives me this color. So this is what aqua is, right? So eventually, if I say I make a rectangle and I want the color to be aqua, it knows, hey, aqua is this shade of blue. And so on for all of these named colors, right? So if, I don't know, what is spring green? Well, it's 0, 255, 127. If you want to look at it, 0, 255, 127. This is apparently spring green. Okay. But we're not just stuck with the named colors in Pygame. We can also define our own custom colors based on the RGB values. So we have a lot of freedom. And we have all these colors, but what's a use for it? Well, we can use it to basically fill in areas. And so the only thing that we have right now is our screen, but we can fill the screen with a color. So here, let's go, I think, yeah, this is the file that we've been working with so far. And I can do it outside the loop because we don't need to do it every single time right now. We just need to do it once. But I can say screen dot fill, and then we need to give it a color. So here is we're making a color, pygame.color. This is like calling the constructor because color is a class and we're calling the constructor. And here we're using a named color. dark orange 3. If we looked in the dictionary, you'll see it probably will show up right here. D. Not too important, but dark orange 3 is this 255.102.0 color. But let's try that. Pygame.color dark orange 3. And so if we run this, you can see, hopefully, it takes a little bit of time, but instead of a black screen, boom, now we have this dark orange 3 screen, apparently. And it still crashes because I kept that code in here. But we can try another one. So again, I said aqua was a color, right? And it's that kind of light blue color. You can see, boom, it's aqua now, right? And so that's using the named colors. You always will construct a color in this way. So pygame.color, that's a class, and we're creating an object of the class. So we're creating a color object. And one way of doing it is by passing a name, a named color. But we can also pass in a tuple. So really quickly, I'm gonna go to this link and look at the documentation. But here you can see pygame.color. We can see the different ways of creating a color object. Color, RGB, or we can say RGB alpha, or we can pass in a color value, whatever that is. And we can look at the code here. So right here, this is apparently dividing colors, whatever that means. So here's where we see the parameters to the function. RGB, these are ints. Anything from 0 to 255 inclusive works, which makes sense because these are the RGB values. Alpha, notice, is optional. And this is a transparency between 0 and 255. And color value was another way that we could do it, right? If we remember up here, RGB, RGB alpha, or color value. And color value is a little bit of a weird one. It can be a string or it can be a tuple of ints. And we can see we used the string version before when we said aqua or dark orange 3. That's providing a string for this color value, and that's how it created the color. But we can also pass in a tuple of ints, and it just returns a color. And look quickly. So for example, if I say C equals this pygame.color, I can actually do something like calling these. I can get the R, G, and B values of the color. So I can print C.R, print C.G, print C.B. And I'm gonna fill it with color C. And so now, instead of just filling it out, I can see I also have the values here, 0, 255, 255. Because that's the RGB values of aqua that we saw previously as well. But if we wanted to come up with our own color, for example, if I go to the color picker and maybe I want, I don't know, this kind of light purple color. So here's my RGB values. I can copy it in. And we saw there's a couple ways we could do it. So I'm just going to put this in the comment. So kind of maybe the simplest way is we can just pass in the numbers to the constructor. So 241, there's just in my clipboard. So I can just pass it in like that. And we can run it. And you can see, boom, we have that color that I picked out. And you can see the values got passed in correctly. Another way that we saw is you can pass in a tuple of ints. So I can put the RGB values inside a tuple and then just pass the tuple inside. And so if I run this, it'll do the exact same thing. But that's just two ways of making your own color. You can just pass in the numbers directly, or you can create a tuple and pass the tuple in. Or the third option, use a color that is predefined. If we go back here. So here's the example that they did. They created this variable red, and it's 25500. And if you do screen.fill red, it's going to fill it with a completely solid red color. And just like here. So there is the alpha channel that I didn't talk too much about. Alpha is basically what determines transparency. And really, there's no effect to what we're doing right now because we only have one color, we only have one thing. But once we start getting into drawing multiple things on the screen, then alpha will actually have an effect. So I'm just gonna skip over it for now, but just know there's an optional fourth number that you can provide, which determines the transparency. So here is an interesting thing. So if we put this inside the loop, can anyone tell me what they think this code is going to do when we run it? So I'm going to put this inside our main game loop, and I'm going to run it. While you're thinking, I'm going to copy it in. I'm going to pause the screen so you can keep looking at that. And all right, so hopefully you had a little bit of time to think. I'm having some issue with copy problems. But let's see. What should happen is it's going to start basically coming up with different shades of red, more or less. So it goes from small shade, like it's basically just changing the R value, starting at 0, going to 1, 2, 3, 4, 5, 6, 7. And the mod is basically just checking if it's divisible by, well, it takes a remainder. And we're going to see mod a lot in this kind of context. Here we're doing mod 255 to make sure it doesn't go outside the correct range. If you mod something by 255, it's never going to reach that value, right? Because it's just going to loop around. So it's going to go 0 to 200 to 254, back down to 0. It's a loop like that. And here, it'll only update if the count is mod 100. So it'll go here. It basically just cycles through a couple different reds. So I have black, we have kind of a deeper red, and now we have a brighter red, and it just does this over time. We can modify the code a little bit, maybe. So if I change this value, it will just update the color a little bit faster. So now you can see it is updating a lot faster, but it's just changing the R value. So it doesn't go anywhere from, it doesn't have any blue, it doesn't have any green, it's just changing the R value. And you can see kind of the effect of the mod. Here we're like at 0 about, and we're starting to go up and up and up. And then once it's at the brightest, that's around 255. And since we're modding, once we reach past 255, we go back down to 0, or more or less 0. It might not be exact, but we get back down very low again. And so that's why we get this kind of up, down kind of effect. And you can imagine we can do this for not just the red, we can also do this for green and blue. We can have different timings, more or less. And that's gonna bring us to the homework and the end of class for today. So really quickly, if I maybe just experiment and if I bring it to not just the RG and B, this fun fact, if the RGB values are all the same color, it's gonna be like a gray color because you're mixing all the colors together. So this is gonna go from gray to black, essentially, or black to white, back down to black. But if you start doing some interesting things, this is just me playing around, I can provide like an offset. So here, instead of being the exact same value for the for the green value, I'm adding a 64. So it's a little bit offset from the red value. And here I can add another one, like maybe 128. And so this won't be grays anymore. It's gonna be, looks like kind of shades of blue now. But now it's going to greens and goes to yellows, goes to reds. So it's a little bit less predictable. I'm not super familiar with how my colors blend together, but with that little change, now it's kind of a little bit RGB values, but not strictly red, not strictly blue, not strictly green. But yeah, that's just playing around. The homework for this week is to update your screen with random colors. And so I have just some parameters to make sure that we're using everything that I talked about. I want you to control the frame rate. I guess maybe I should say there's an epilepsy warning. You don't want to flash your screen with different colors really fast because that can it can hurt certain people. So we want to limit the frame rate and how fast it updates. So we want to set the frame rate to 220. So that's going to be using the clock.tick trick to limit the speed. But we also don't want to update every single frame. We only want to update every 5 seconds. So you want to figure out how, okay, if I know my frame rate is 20 and I want to update every 5 seconds, how many frames is that, right? And to test it, you can just run your code and maybe have a clock next to you and see if it's actually 5 seconds. Of course, if it's a little bit more, a little bit less, that's probably just because your computer is a little bit random and that's not a problem with your code. But you don't want it running super fast or not changing at all. And for testing, if you wanted to do it every second or every 2 seconds, so it's a little bit faster, is perfectly fine. The only thing I didn't, I guess, cover is how to get random colors, but that's pretty simple if you know how to generate random numbers. So a random color is just a random R value, a random green value, a random blue value. And one way to do it is with random.randomInt. And so this is something that you have to import. So I can import random. And random.randomInt will give me a random number between a certain bounds. So here, I'm gonna say rval equals random.randomInt, and then anywhere from 0 to 255. And I'm just gonna repeat this for the G value and the B value. And maybe just to demonstrate the last thing for today, I'm gonna put the R value, the green value, the blue value. Oops, I didn't typo. And every time I run this now, I should be getting a different color. So this time I got a green. Next time I get a purple, and so on. So this is how you can get a random color. You just generate random values for RG and B. So I know I'm at exactly 4 o'clock now.
Oh, sorry, Jack. Well, I missed it when I was writing down the code. But what were you supposed to import again?
Oh, yeah. For the random,
Oh, yeah.
yeah.
Okay.
So it's just import random.
For me, it turns gray.
Yeah, so it's gonna be random every single time that you run it, or at least it should be. Because random.randomInt, what it does is it generates a random number between the values that you put here. So since I
Oh,
say 0 to
I meant the code was like gray, the text.
oh, so if you import but don't use it. So for example, if I didn't have these codes, if I commented out, now it goes gray for me too. And the gray
Oh,
just says, hey, you've imported this thing, but it's unused. So if you hover over, PyCharm is actually pretty smart. It'll say unused import statement, import random. It basically says you imported it, but you're not using it. So why are you importing it, basically? It's not an error. It won't cause your program to break. So it doesn't complain too much. But it says, hey, you know, maybe look at this. So that's why it's grayed out. But once you use it somewhere, it will not be gray anymore. So that's the end of the class. If anyone has any questions, happy to answer them now. If not, the homework is here. I'll be making a Google Classroom post as well, and you'll be able to submit there. You can just submit the game file, and I'll take a look at that. If you have questions, my email is up on Classroom. It's also on the GitHub repo, and all the code is going to be there too. But that's all I had. Thank you for sticking around with me another week, and I'll see you next week if you don't have any questions.
bye.
Bye. Evan, did you have any questions?
No.
Okay.
Bye.
All right. See you next week. Bye.
See you.